So there are two different types of dilutions. Number one is simple dilution. Number two is serial dilution. Now, I haven't seen any question related to serial dilution in your paper. Most of the questions are from simple dilutions. Okay. Serial dilution, it comes in your AS level, so no need to worry about it. Okay. So there are two different types of dilutions. Number one is simple dilution. Number two is serial dilution. Now, what is the meaning of simple dilution and what is the meaning of serial dilution? As you can see in these diagrams, how the simple dilution is prepared. For the simple dilution, we are going to have a stock solution. And from this, by using this stock solution, each time we are going to use this stock solution in order to make different concentration. For example, we are going to make the 3% concentration by using the stock solution. We can make 2% solution by using the same stock solution. We can make the 1% sucrose solution or salt solution or any solution by using the same stock solution. So if we are using the same stock solution in order to make any dilutions, such type of dilution is called what? Simple dilution. Okay. Whereas what happened in case of serial dilution? In serial dilution, you create a series of dilution with decreasing concentration by moving a fixed volume of liquid from one tube to the next instead of always going back to the original bottle. Okay, you use the previous tube as your stock for the next step. As in this case, the stock is for the 2% solution, the stock is 4% solution. And in order to prepare 1% solution, the stock solution is 2% solution. Okay. Now we are going to see some examples related to simple dilutions and serial dilutions in order to make it more clear. Now, let's look at this example. For example, a 4% stock sucrose solution is diluted. To make a 1% sucrose solution, you are required to prepare 10 cubic centimeter of 1% sucrose solution. So in order to solve the simple dilution questions, we are going to use this formula M1V1 is equals to M2V2. Now, what is M1? M1 is the concentration of stock solution. In this question, what is the stock solution? This 4% is the stock solution of sucrose. Okay. And what is V1? V1 is the volume of stock solution needed to prepare 1% of sucrose solution. Okay. M2 is the concentration of diluted solution, that is this 1% sucrose solution that we need to make. So in case of M1V1 is equals to M2V2, what is M1? M1 is M1V1 is equals to M2V2. Let's suppose if we want to make 1% sucrose solution out of this 4% stock solution, what is M1? M1 is 4%. V1 we don't know. M2 is 1%. V2 is, as we need to prepare 10 cubic centimeter of 1% sucrose solution, so V2 would be 10 cubic centimeter. So now we need to calculate it. V1 is equals to 1 divided by 4. What should be our answer? When we divide 1 with 4, our answer is 2.5 cubic centimeter. So when we are going to use 2.5 cubic centimeter of stock solution, let's suppose if we are going to take in a beaker 2.5 cubic centimeter of stock solution and we need to prepare 1% of sucrose solution out of this stock solution. And the final volume of this 1% stock sucrose solution should be 10 cubic centimeter. So how can we make this 2.5 cubic centimeter 10 cubic centimeter? How can we make it to 10 cubic centimeter? We need to add in this 2.5 cubic centimeter, we need to add 7.5 cubic centimeter of water, distilled water, in order to make it 10 cubic centimeter. So whenever we are going to add 2.5 cubic centimeter of stock solution, and in this 2.5 cubic centimeter of stock solution, whenever we are going to add 7.5 cubic centimeter of distilled water, we can make 10 cubic centimeter of 1% sucrose solution. Is this clear to you? Now try to make another dilution out of this 4% stock solution. Let's suppose if the examiner asked you to make 10 cubic centimeter, 10 cubic centimeter of 3% sucrose solution out of, when you are provided with 4% sucrose solution, which is a stock solution. Okay, so in case of simple dilution, you will always be provided with a stock solution, and you are going to prepare dilution from this stock solution only. Okay, each time stock solution is not going to change. Stock solution will remain same. And which formula we are going to use? We are going to use the formula M1V1 is equals to M2V2. Now, what is M1 in this case? Yes. Can anybody tell me what is M1 in this case? You need to participate, beta. Quickly.
4.
Very
4.
good. 4, because this is a stock solution. What is V1? We don't know, because we need to take out some volume of the 4% stock solution in order to make 3% sucrose solution. Okay. So V1, we don't know. We are not aware of it. We need to find out the V1. What is M2? The solution that we need to form. So what is the solution that we need? What is the concentration that we need to form? Yes?
3.
Yes? Hello? Yes?
3.
3. Very good. So concentration could be given in the form of percentage or mole per dm cube, or examiner can write only m. M means molar. Okay. Now what is V2? What is V2?
10.
Very
10.
good. 10 cubic centimeter should be our final volume. Okay. So V1 is equals to 3 times 10 is equals to 30 divided by 4 is equals to 30 divided by 4 is equals to
7.5.
7.5. So how can we make it to 3%? How can we make it to 10 cubic centimeter? By adding in this
7.5.
7.5 centimeter.
7.5 cubic centimeter, how much volume of distilled water should be added to make it 10 cubic centimeter?
2.5.
Plus 2.5 cubic centimeter of water. So whenever we are going to add in 7.5 cubic centimeter of stock solution, if we are going to add 2.5 cubic centimeter of distilled water, we can get 1%, sorry, 3% of 10 cubic centimeter sucrose solution. Is this clear? Is this clear? Because we are going to solve some questions from past papers, right?
Yes.
Now, let's look at the past paper questions. Now, you are given 1% glucose solution. Describe in detail how you would use it to produce 5 cubic centimeter of 0.5% glucose solution. So what is the stock solution in this case? Yes, we need to use the same formula. M1V1 is equals to M2V2, because in case of simple dilution, we are going to use the same formula. M1V1 is equals to M2V2. What is M1? M1 is the concentration of stock solution, right? So what is the concentration of stock solution?
1%.
1. Very good. 1. What is the concentration of our desired solution that we
0.5.
need to make? 0.5. Very good. What is the volume? What should be the final volume that we want to make?
5 centimeter.
5 cubic centimeter. Okay. So the volume of the stock solution that we need to extract is V1 is equals to 0.5 times 5 cubic centimeter is equals to
2.5.
hmm?
2.5.
2.5 cubic centimeter. So what should we do? How can we make it 5 cubic centimeter? And 0.5% glucose solution, what should I write? We should take, yes, yes,
Double.
2.5 cubic centimeter of of what? Of what should be taken?
Distilled water.
No, 2.5 cubic centimeter of what? What is this? 2.5 cubic centimeter of what? What is this? V1 is
Glucose
2.5
solution.
cubic centimeter of, huh?
Glucose
Glucose.
solution.
So stock solution, right? 2.5 cubic centimeter of stock solution, or 1.0% glucose solution dissolve in, how to make it 5 cubic centimeter? Dissolve in
2.5
2.5 cubic centimeter of,
distilled water.
very good, to make what percent of glucose solution?
0.5% glucose
Very
solution.
good, 0.5% glucose solution. Is this clear? Clear? Clear?
Yes, yes.
Yes.
Now let's solve another question to see if it is clear to you or not. Now look at the next question. You are given 50 cubic centimeter of a sucrose solution containing 0.8 mole per dm cube. So what is a 0.8 mole per dm cube? I told you the concentration could be given in the form of mole per dm cube or percentage. So in this question, it is given in the form of mole per dm cube. So what is 0.8 mole per dm cube? M1 or M2?
M1.
What is M1? Stock
0.8
solution.
more.
M1 is, because we are preparing simple dilutions out of the stock solution always. Okay. The stock solution cannot change. Okay. So what is the stock solution in this case? In this case, the stock solution is of 0.8 mole per dm cube. So 0.8. What is M2?
0.4.
Very good. 0.4. This is the concentration that we need to make. So 0.8 was the stock solution. If we want to copy the diagram, and we have to make this 0.4 mole per dm cube solution. And what should be the volume of this 0.4 mole per dm cube solution? 100 cubic centimeter.
100.
So what should the volume that we should write in V2?
100.
100. Very good. So volume of the stock solution that we need to find out. So V1 is equals to 0.4 times 100 is equals to
40.
40 divided by 0.8 is equals to
50.
50. So what should I write? So 50 cubic centimeter of what? 50 cubic centimeter of 50
Um,
cubic centimeter of
Stock solution.
Very good. And what is this stock solution? 0.8 mole per dm cube. Okay. So what should the statement that I write? Yes, Aryan. Yes, help me out. Please. Aryan.
This
Yes.
we
What should I
will
write?
write uh, 50 centimeter cube of 0.
50 centimeter cube
Of
of
0.08
0.8 mole per dm cube.
of sucrose solution
Okay. Is dissolved in of
distilled
sucrose
water.
solution is dissolved in
Distilled water.
what should be the final volume? 100 cubic centimeter. So how much volume of distilled water should be taken? 50 cubic centimeter of 0.8 mole per dm cube of sucrose solution is dissolved in
50 centimeter
very good, excellent, in 50 cubic centimeter of
distilled water.
Distilled water to form what?
100 centimeter cube of zero point 0.4
Uh, uh,
mole per
uh, uh,
deciliter.
uh. Okay, fine. To form, very good. To form 0.4 mole per dm cube, 100 cubic centimeter of 0.0 mole per dm cube solution. Very good, excellent. Now next. Now, this is the table that is provided by the examiner. In this table, where is the stock solution? Keep this formula in your mind. M1V1 is equals to M2V2. Sometimes you can write, rather than M1, you can write C1V1 is equals to C2V2. Okay. So M1 or C1, both are the same thing. M1 means polarity and C1 is concentration. Both of them are the same thing. Okay. So now where is the concentration? Where is the stock solution concentration in this table? Yes.
The first
Quickly.
column, the
Huh?
volume
In the,
mole.
so what is the concentration of stock solution? Yes.
Is
What
it
is the
one?
concentration of stock solution? Huh?
1 mole per decimeter cube.
Yes. Always look for this unit or percentage in order to look for the concentration. Whenever you want to see the concentration, you need to look for these units, either percentage, mole per dm cube, or molar. Simple capital M. Okay. So 1 mole per dm cube sugar solution. So this should be M1 or M2.
M1.
M1, very good. So stock solutions concentration will always be M1. Now, what the examiner is asking, look at this question. This is not provided. This is the part of the table that is asked in the question. So what the examiner is asking, concentration of sugar solution. That is M2. What is V1?
8.
What is V1? 8. Very good. What is V2?
12.
12. Is it 12? What should be the final concentration? Final
Um,
concentration of all the sugar solution.
V2.
So what is V2?
Means we have to find V2, right?
No, we have to find M2, not V2. So what should be the final concentration? Look at the entire table and find out the final concentration that they are using it in each test tube. What is the final
It's 20.
volume that they are using in each test tube? Yes?
It's 20.
Very good. It should be 20. So if the final volume for this concentration of sugar solution should be 20. So M2 is equals to 8 divided by 20 is equals to how much?
0.25. No.
8 divided by 20.
Wait.
Just use the
It's
calculator
0.4.
bit.
0.4.
Point 0.4.
4.
So our answer is 0.4. Is this clear? Clear,
Yes.
Aryan?
Yes, miss.
Okay. So in case of simple dilution, we will always use the formula M1V1 is equals to M2V2. Always look for the stock solution concentration and what the examiner is asking. Sometimes examiner will ask you about the concentration, the final concentration that we need to find out. Sometimes examiner will ask you about the volume that we should take, the volume of the stock solution that we should take in order to find out, in order to make the known concentration. In this question, the concentration was unknown, whereas the volume was known. Whereas in the previous questions, the volume was unknown, but the concentration was known. Okay? Now, look at this question. The student used 3 different concentration of salt solution and potato tissue that had been cut into cylinders. Using the information in table 1.1, decide the volumes of S and W needed to make 50 cubic centimeter of 0.5 mole per dm cube salt solution. Okay, you need to make 0.5 mole per dm cube salt solution. Complete table 1.1 by writing in the volume of S and W needed to make the 0.5 mole per dm cube salt solution. So in beaker S1, the final concentration of salt solution is 1.0. What is M1 here? What is the stock solution? What is the concentration of stock solution here?
1.
1. Very good. In S2, what is the volume? Do we know about the volume?
No.
No. Okay, so we need to write down 1. What is M2? In case of S2, what is M2?
0.5.
Very good. Do you have any doubt? Aryan, why you are
No.
not participating, bete? What is V2? V2, what should be the final volume
Which you have to
of
find out.
0.5 mole per dm cube? Yes? What should be the final volume
50.
of 0.5? 50. Very good. 50 cubic centimeter. Okay. So what is V1 is equals to 0.5 times 50 is equals to
25.
25 cubic centimeter of
Uh, Distilled water.
mm,
A salt solution.
is this V1 with salt solution, stock solution or final concentration?
Stock solution.
Stock solution. So what is stock solution? 25 V1 is equals to 25 cubic centimeter of 1.0 mole per dm cube of salt solution. Clear? So we should write it over here 25 only. No need to write down the unit in the table. Okay. And what should be the volume of distilled water in order to make it 0.5? Or in order to make the final volume 50?
25.
25 cubic centimeter of distilled water. Is this clear?
Hmm.
Now stop the recording.